Go to presentation.
Right.
Yeah,
We'll get there.
Yeah.
Good morning, everybody. At the workshop in Athens, of the QUALICHeCK workshop, one of the speakers, who's an architect, Nikos Finikakis, emphasized that in seeking the latest high technology solutions, we shouldn't overlook the quality of traditional design. And we agree with that. We are a smart technology, but solar shading is also a traditional technology. The earliest shading that we know of was in the Middle East over 2,000 years ago, when alabaster slats were used across window openings. These became known in Europe as Persians, a name still used for slatted blinds in Scandinavia, and almost certainly described as Phoenicians in English that went wrongly and became Venetians. And then glass was invented, and shopkeepers since the 17th century have protected their products with awnings. Then air conditioning was invented, and we forgot that if you stop the solar gain before it gets to the glass, you don't have to pay to use the energy to get rid of it. So technology is not new. It is just that its energy-saving potential is generally significantly underestimated. When energy was plentiful, it didn't matter. It does now, and we have to rethink our approach to design. Glass alone is not the solution. Glazing that is designed to keep the heat inside in winter will do the same in summer. The drive to make buildings more insulated and airtight is causing buildings to overheat. This lovely passive house has big south-facing windows to harvest the heat in winter. And guess what? It harvests the heat in the summer as well. In fact, research shows that without shading, passive house will experience overheating in most months of the year. Shading is actually the enabler of large glass areas. The building of the Shard in London was only possible as the automated shading in the double-screen facade achieves a GTOT value as low as 0.12. That's 88% rejection of solar gain. But most in the glazing industry only focus on U values. To achieve the best quality of our products, our industry needed to improve the understanding of the benefits of shading. So we commissioned a scientific report, Dynamic Shading Solutions for Energy-Efficient Buildings, by Professor Mick Hutchins, which confirms in detail that shading will always improve the energy performance of the window. And this is summarized in our 2015 position paper, A New Vision on Solar Shading, which is available on the ESSO website. As mentioned, we then undertook a survey of EU member countries that led us to developing the ESTA database. Quality of design needs quality of information. In the UK, we have more of a problem, as we don't think it gets hot. So we spend proportionately more on cooling than any other EU country, because others have more of a culture to design the solar gain and design for solar gain, and that mainly comes down to shading. But it does get hot. So we started a study, assisted by ESSO, with our National Energy Federation, to identify how to re-educate on the benefits of shading. The report was signed off yesterday. It highlights that there needs to be a better understanding and guidance from our own industry, and also our National Research Laboratory, EPBD conformance of our regulations, building performance certification, and building modeling software. The problems with certification and modeling have a wider implication as they are used throughout Europe. We had assumed that building modeling software would be accurate in its calculations, but found that the one that we used for the report from one of the leading companies uses calculations from over 30 years ago, when we last had a climate problem, and the building design problem issues were completely different. NEF then modeled it with a tool that had no benefit at all for shading. So we remodeled with an American tool, and that showed a 45% reduction in the total energy running costs with external shading. The poor quality of the first software creates an absolutely unacceptable difference that identifies that a problem that we have to resolve. There's no point in providing accurate quality product data if it is not applied correctly. A recent report highlights the problem of overheating in London office buildings. It is rightly concerned with the possibility of increasing temperatures, needing us to future-proof our designs. But possibly, due to the quality of the modelling, we're not even meeting the demands of current temperature levels in our design. The ESDA database does not simulate. It provides the validated data that you should use when modelling. The most accurate software tool that we are aware of is the EQUA model. This includes ESBO, which is a free-to-download tool for early simulation of building performance optimization. The detail for the calculations for this were developed in conjunction with the Swedish Solar Shading Association. EQUA conforms to all EN standards for solar shading as well as to the relevant ISO standards. The project with NEF will be continued to promote the improvement of building modelling programs and to develop guidance for users of modelling systems. As for quality and design, our data has to be interpreted correctly. Now that the ESDA database is in place, our emphasis will be to expand the advice section into comprehensive technical guidance for experts and also simple to follow advice for each of the key points for the users of the database. Currently, the leading UK environmental assessment method and rating system for buildings does not apply credits for solar shading, other than for glare control. With the support of the NEF study, that is a situation that needs to be addressed, as the scheme is also used internationally. There are more credits to be gained by adding a bicycle shelter than for glare control, and none at all for improving the energy balance of the building with shading. That is clearly not correct for the future-proofing of our designs. Education is the key, as without a clear understanding of performance, it is impossible to have quality specification of product. Even in the countries that do have a culture of external shading, there can be a feeling that we need it because we've always used it, rather than a full understanding of how the benefits can be maximized. In less aware countries, there is a distinct lack of understanding of how the sun actually works. This is not a simple task. There is no such thing as the perfect solution. It is site-specific to a prioritized list of requirements. Indeed, the most effective can be a combination of two shading systems. 2 blinds to a window may sound an expensive option, but it's often the most cost-effective. Even when efficient design is achieved, it is no benefit if the occupier does not understand the design intent. That is even the case where there is a culture of using external shading. One of the key areas that we have identified that will improve the quality of building in use is the operating instructions to the user. Too often these are too complex or pro forma standard issue that are not product or site specific. It's also further complicated when the supplier installer is working for the building contractor and there's no contact with the end user. Our studies have shown that energy efficiency could be improved by over 10% if the blinds and shutters already installed were used efficiently. Behavioural change through the process from concept to use is key to quality in use and is the primary objective of the education package that ESO will be delivering on the ESDA database. Quality of training of installers and levels of qualifications are mostly addressed and delivered at national level. Local building codes vary between EU states, and it's not possible to design a training package that will meet all needs. There is, though, a sharing of guidance between ESO member associations. It is essential that those delivering the product understand the performance, as they are customer-facing, and obviously the highest quality product will not perform if it is not installed correctly or if there's a failure to instruct on how to achieve the best performance. Training videos that you can see here and webinars are now being used. This is both for the installer and the measurer salesperson. In the UK, we have developed a national vocational qualification. Training is mostly on the job and takes about a year to achieve a level that is confirmed by an approved independent assessor before the qualification and identification card that you can see there is awarded. For the shading industry qualification, this became a requirement last year. It is now needed to work on most construction sites, and it is expected in time to be a requirement for most government premises. It is also a qualification that is a confirmation to the domestic consumer. So, training, education, behavioural change and performance awareness supported by accurate data are the key to improving the quality of products and their use. Thank you very much.